Okay, let's start our first coding exercise. Yeah. This coding exercise we do it early for two reasons. First, we want a baseline, yeah, and secondly, we're going to compare that baseline with all the results of the other classifiers that we used on that data set. So we're going to use the Internet Movie Database dataset. Yeah? So that contains reviews, and reviews can be positive or reviews can be negative. Yeah? So we want to capture that from a review. Details on the dataset I have given in video number 77. So if you want to get a little bit more of background, feel free to go and look at that video. But basically one of the challenges here is that a movie review is a text, right? So we need to convert that text in a list of numbers, a list in Python of numbers. Yeah? This tokenization has been executed already because this dataset is a standard dataset in Keras. So this has been done for us. But theoretically, if you would need to start from scratch, you need to tokenize your text. When you have a list of numbers, that's still not good enough because we know that TensorFlow or Keras only accepts tensors as input. And a tensor in Python is called an array. Yeah? So it's called an array. Here we go. Okay, so we need to convert that to a tensor, the tokenized list. How do we do that? Well, it's not a very efficient way to do it, and we'll see more ways of doing it later in this course. But basically what you do is you write your reviews, all your reviews here, and there's 50,000 of them. Yeah? And then here you have your vocabulary. These are the columns. And the vocabulary, in our case, will be 7,500 most frequently used words. So each of these words you're going to have here, you're going to have 7,500 columns. Yeah? And when you take a review like movie is great, what you're going to do is you're going to put a 1 in the column of that word. So I put a 1 in great, a 1 in is, and a 1 in movie. Don't worry about the sequence here. The sequence doesn't matter. Okay? And this we do for all 50,000 reviews. So you can imagine the sparsity of this tensor is going to be big. Yeah, because a lot of value is going to be 0. Yeah? Alright, so let's talk about the network that we will use. As a data scientist, you need to make quite a number of choices. One is the number of layers you're going to use. And here we're going to use 3 layers. Then the type of layers. Our layers will be dense because we haven't seen any other layers up to this point. The number of units in the layer. We go for 16, 16, 1. Yeah? The last unit as activation function we will use relu, relu, sigmoid. And remember the sigmoid allows you to give a probability 0 or 1. This will be good review, bad review. Optimizer we will use RMS prop. So no big surprise here. Adam would have been another option. I just want you to take a look at one layer now. We have 16 units. Remember these units are these circles. So we have about 16 of them. Yeah. And so your review is gonna go to these 16 units. And each of these units of course has a weight. Yeah. The output of that unit will be the relu, because there is a relu layer here as well, of the dot product of W and the review plus B. W are your weights. Yeah. The shape will be number of so the input times 16. This will be the shape of the dot product of W and your review. So you know what the dot product is, huh? A dot product between two vectors A and B, yeah, is basically the projection of that vector to B. That's the dot product. So here in this case, what you're gonna do is your review, you're going to project it to a 16-dimensional space. Yeah, this is basically what you're gonna do. Now, why don't we pick 512 or 1024? Now, well, of course, the more inputs you have, the more flexible you are, but the risk of overfitting increases. So we've chosen 16 here, but believe me, this will be one of the things you as a data scientist will need to do. And probably what you do is you're gonna try a few values and see how your result is. All right, so let's get going and start our first coding session with respect to neural networks.